Hello, my dear students. Myself, Rajkumar Kalia, has worked in various institutions in India, so have the experience of various institutions in various states. My observation is all students are having same IQ, no difference in the IQ, no difference even in the thinking at all. All kinds of students I am getting everywhere. Only those students, those who have not got good exposure in the early life, say from the rural area, only they are a little bit in trouble. Otherwise, there is no difference at all. I have seen some students from the rural area, they are very intelligent, sharp, though the percentage is less. They have to work hard to come up now only. Otherwise, students are as usual. Not here even I am hearing about the students in the different countries. They are all also the same type. We are giving exposure to our students in different way. In USA, they are getting exposure in some different way. That is the difference. Otherwise, whatsoever exposure we are giving to you people, you are not in any way less than that of the USA students. Rather, I would like to say better than the students in USA, what I am hearing from the others. So please come up, take interest. I am helping those students, those who are not taking interest in the class. If the students are taking interest in the class, then I think no help, extra help is required. Anyhow, some are naughty, they need my help. They are not taking interest in the class, so they can see my video at home. Somehow, if you have missed one chapter, you have missed one module, you have missed one topic, you can see from my YouTube. Like that, I am helping you people. It's free of cost for the poor. Those who can't pay for the tuitions and all that, they can make use of my tube. I am also thinking of online classes. Maybe paid, but payment will be very, very less. Because I have observed that if students are paying, some students are paying little bit amount, they take more interest. From my side, you are free YouTube will be available, even if I will start some paid classes. So today, I am going to teach you multiple integral. Multiple integration. It's not, I can't say few students. So many students have called me for this multiple integration. But I feel it's quite simple. It's as simple as usual integration which you have done in 12th. But you have to choose which integration you are supposed to do first. That is the difference only. Say what you have done in the previous classes. Suppose I want to integrate x square minus x plus y. So its integral will come out to be increase the power by 1 divided by the increased power, increase the power by 1 divided by the increased power, integral of 1 is x plus c. This is what you are doing in the previous classes. Now, if function is with two variables. Function is with the two variables, and we want to integrate, say, x plus y. We want to integrate x plus y with respect to x and with respect to y. So we are supposed to put two integrations. One with respect to x, second with respect to y. This is what we called multiple integration, because we are integrating more than once. So if we are integrating more than once, we call it as a multiple integration. And integration will be as usual, as we are doing. Say here, I want to integrate x plus y with respect to x and y. What I will do? Here dx comes first. First I will integrate it with respect to x. Integrating with respect to x. You know, in partial differentiation, del u say del x del y. How we used to differentiate? If I want to go for del u, del x, I used to differentiate only x terms, keeping y constant. Similarly here, I will integrate x keeping y constant. That is the concept. Same as that in differentiation, partial differentiation. So here you can say it's partial integration. I want to integrate it with respect to x. What I will do? I will consider y as constant. 1 dx I will eliminate, and 1 integration I will eliminate. Only one is left. Integral of x square by 2. This integral I am using, plus y constant, and integral of dx is x, so y as it is, integral x dy. I am elaborating it a little bit. I will keep integral as it is. Inside I will write integral x dx, integral y dx, keeping this dy as it is. This dy is for this outer integral. Here I will integrate it, x square by 2 plus y constant. So integral of 1 will come out to be x. That is how I am putting here x square by 2 plus y, integral of 1 is x dy. That is how I can eliminate one integration. I have discussed it fully compared it with partial differentiation, and here I have written separately how I am getting this. So after getting this, now I will integrate it with respect to y. Integrate with respect to y. Now see here, it's x square by 2, thus it's constant, and integral of 1 will come out to be y plus x constant, integral of y square by 2. So first I have integrated with respect to x, eliminating the first integration sign, now the second integration sign. Because we are operating, we are integrating. X square by 2 constant, for 1 will get y plus x constant for y square by 2. Like that we can integrate. So here I think xy by 2 we can take common, we will get x plus y. So that will be the double integration. That is how you are supposed to go for the double integration, that is integrate twice. First I have integrated with respect to x because dx was first. If dy is first, integrate with respect to y first. So after integrating the first dx, then go for the second. So like that we are supposed to integrate it. I have integrated it twice, thus we call it as multiple integration. Now see the next example. Double integral of xy dy dx. First here it is dy. So first integrated with respect to y. Integrate xy dy dx. First is dy. So first integrate with respect to y. So we'll keep x constant. One integral and dy will go away. Y x constant equals integral x constant with respect to y means y square by 2 dx. 1 by 2 is absolute constant. Now integrate with respect to x. We will get half. Y is constant, for x it is x square by 2. Y square constant. So thus it is 1 by 4 x square y square. Like that we are supposed to solve the sums. How simple? Go on integrating 1 by 1, that's it. Keeping the other constant as we have done in partial differentiations. See now, triple integral. Triple integral of x plus y plus z with respect to dy, dz, dx. Quite simple, no limit, nothing like that, no variable. So first we'll go with dy. It means first integration is with respect to dy. Integrating with respect to y. Keeping x and z constant. So thus we will get I equals one integral will go x constant, and we are integrating with respect to y. So for 1 we will get y. For y, y square by 2. For z, zy. dz, dx. See here how I have written integration of x with respect to y. X is constant, take it out. Integral dy. X constant, integral of dy is a y. That is how I have put here xy. Similarly for z. Z constant, integration of dy is a y. So like that I have explained it on the left side. We are putting that y. Integrate with respect to z, because now z is there. Only one integral is left. Now with respect to z, it means xy is constant, then integration of 1 will come out to be z, plus y square by 2 constant, then z. For z, z square by 2 y constant. Now we are with the dx. Like that we will get. Integrating with respect to x, I equals yz constant, x square by 2 yz. Y square by 2 z, and integration of dx is x. Z square by 2y, then x. So like that we are integrating with respect to x, this integration will also go. So that will be the integration. Now I think we can take common 1 by 2 xyz, xyz and xyz. We are left with x plus y plus z. So like that you can integrate. This is the simple integration I have discussed with you with respect to the multiple integrals. We are doing multiple integrals, but the simplest possible integration I have discussed with you people. There is no limit. So if no limit is there is no problem whether we are integrating it with respect to dx, with respect to dy, with respect to dz first. You can use any, and then we follow the rule. which comes first, we'll integrate with that first. Here dy is first, so we will integrate with dy first. Then it is dz. After that we will integrate with the z. Then it is x. Then we will integrate with the x. Quite simple. Which comes here first, integrate with that. Now come to, if we are having some limits, then how to do? Now integration with the limits, with constant limits. Still I am not discussing the variable limits, constant limits. Dx comes first, integrating with respect to x. Outer integral 0 to 1 will remain as it is. Integrated with respect to x. X square by 2, y constant. For 1 it will come out to be x. Dx will go, then dy. Now what about limits? Limits are 0 to 2. Limits for x are 0 to 2. So like that you will write it. Integrate with respect to x, x square by 2 within the limits 2 to 4. Y constant, take it out, integral will come out to be x within the limits 0 to 2. Use the limits. One by 2 constant. For x put 2 square 4 minus 0. Upper limit minus lower limit. Upper limit 2, lower limit 0. We'll get it as, that is 2 only 2 we are getting, plus 2y dy. So after the limit, this is what we will get. Now integrating with respect to y. It's 2 integral with 1, that is 2y. See carefully, 2 constant, then integral of 1 will come out to be y because we are integrating with respect to y, plus 2 integral of y square by 2, and y is with the limits 0 to 1. We will get 2 for y upper limit minus lower limit. 2 we can cancel, y square upper limit minus lower limit. So like that we will solve it. It will come out to be 2 plus 1, that is 3. So that will be the answer for this question. Integrate limit 0 to 3, 0 to 2, 0 to 1, xyz dx dy dz. There is no limit of variables, just the constants. So do it according to the dx dy dx. So first integrate it with respect to x. Integrate with respect to x. One integral will go, that is the last one. 0 to 3, 0 to 2. Integrate with respect to x. X square by 2, y and z constant as it is, and x is with the limit 0 to 1. Dx has gone, dy dz. I equals 0 to 3, 0 to 2. Upper limit 1 or 1 by 2, absolute constant, take it out. 1 square 1, 0 square 0, thus it is 1 only. Y, z, dy, dz. So overall we are getting 1 by 2. Absolute constant, take it out. 0 to 3, 0 to 2. Yz, dy, dz. Integrating with respect to y now. I equals 1 by 2 integral, only one integral is left. We are integrating with respect to y. Y square by 2 and limits are 0 to 2. Z as it is constant. Dy has gone, dz only. I equals 1 by 2 and 1 by 2 we are getting here. 1 by 4 because 1 by 2 is absolute constant. Integral 0 to 3. Upper limit 4, lower limit 0. 4 minus 0. This 2 we have taken out. 4 minus 0, that is 4. Then it's z dz. This 2 we have taken out. 2 square is 4 minus 0, so we are getting 4. I equals absolute constant, we can cancel. 0 to 3 z dz. Integrate with respect to z. I equals z square by 2 within the limits 0 to 3. Upper limit 3 square minus 0, that is 9 by 2. So that will be the answer. Like that we are supposed to solve. So today I have solved sums with constant limits. In the next video I will give you the sums with variable limits, then how to decide and how to solve. And at the end, if you are feeling the concept is clear, I am making the concept easy, I am making the subject easy, then kindly subscribe and put the icon bell so as to get the next video. If you feel I have explained nicely, then thumb up, but it's your wish. Thank you, good night.